This is Grace and Matias, and we're going to be presenting on the paper on mathematical models of a three-nation arms race and some other scenarios that we came up with. So to begin with, we decided to give a little introduction on the author of this paper. So the author of the paper is John E. Hunter. He was a professor of psychology at Michigan State University, and he got his PhD in quantitative psychology at the University of Illinois. He was very much engaged in the mathematical side of his career. Co-authored 4 books and co-authored over 200 articles on confirmatory and exploratory factor analysis, measurement theory, and methods, statistics, and research methods. For this specific article, he based his investigation on the work of Louis Fry Richardson. He was a British mathematician, physicist, and psychologist. He was chairman of the physics department at Westminster. He was known in the scientific community for being a pacifist, and he used mathematics in the study of the causes of war and published his studies in generalized foreign politics, arms and insecurity, and statistics of deadly quarrels. This article written by Hunter was published on 1980, which, to give some historical background, was in the middle of this period of time called the Cold War. This was a time of very tense geopolitical situation between the United States and the Soviet Union and their respective allies, which basically divided the world into 2 sections known as the Eastern Bloc and the Western Bloc. Both of these global powers sought to demonstrate their superiority by arming their militias with more and more powerful equipment, which initiated a arms race. It is not very clear where exactly the Cold War started, but some authors would say that 1949 was one of the dates where it's pretty much agreed where it started, when the Soviet Union successfully tested its first atomic bomb in what's today Kazakhstan.
The author defines some assumptions before actually explaining the model of the paper, specifically stating that the models are based on an us versus them basis. So it's either you are us or you are the enemy. Another assumption is the enemy will always look for an opportunity to attack, meaning that the arms expenditures of one nation is based on the intelligence that they gain from other nations. The enemy is assumed to not attack unless they have some margin of strength, which in the paper is presented as mu. And it is assumed that we feel threatened if the enemy has this margin of strength over us.
In order to come up with his model, Hunter decided to make a connection between how we feel and the amount of policies we take, where we is pretty much the nation that is undertaking these decisions. So we feel threatened if the enemy's strength is greater than or equal than ours, plus this margin of error that was mentioned before. And we feel safe if this is not the case. Rearranging these variables, he came with this relation, which is happens to be proportional among these variables, which yields this model where our policies are directly proportional to the enemy's minus ours plus the margin of strength. In the first scenario, there is a all against all model. So in this case, each nation is isolated from each other, which means that they do not interact among themselves, only to check on the strength of the other nations. In this case, the concern of each of the nations is the potential alliance between the other two nations. So, in order to apply the model, we need to be able to recognize for each nation which one is the enemy and which one is on our side. To make this model more simple, we will use the countries of the U.S., Russia, and China, and then we will replace these names by the variables x, y, and z respectively, in order to make the math more simple. So, for the United States, following Hunter's model, we see that the enemy in this case would be the other nations of Russia and China, and on our side we only have our nation. Thus, replacing each country by their respective variable, we get this equation. Now, doing the same for Russia, we get that the enemy would be a potential alliance between the US and China, and on our side we would have only Russia plus the margin of strength. Then, now again, replacing the countries for their variables, we get this equation. And now for China, the potential enemy would be the US and Russia, and on our side we have China and the margin of strength. So we get the equation as follows. Now, these are all the equations we get, and as you can see, they're kind of similar, and we will expand more on how we get exactly to them and how to analyze them.
If we rearrange the equations for delta x, delta y, and delta z given in the first scenario, they can be written as the system of equations found here. And as you can see, their coefficients can be placed into a coefficient matrix here. Using the coefficient matrix, we can generate eigenvalues that will later be used in the solution. Sage was used for this. Down at the bottom, highlighted in red, this a plus 1 term is one of the iterations that we see in the solutions that was generated by the author of the paper, as well as the negative 2a plus 1, or in the paper it says 1 minus 2a. You can see the equations are set up using these iterated terms that we saw from the generated eigenvalues previously, and they are paired with some coefficient that is dependent upon the initial conditions set by the author. The author never defines that, so it's very hard to make the equations from scratch. In the paper, they describe the term as 1 minus 2 alpha, this term here being between 0 and 1. So as n approaches infinity, this term approaches 0. That means the equation can be simplified into this term, where the only difference is their averages presented by a naught. This is a situation where we would have an equilibrium. So, specifically looking at this term, AN, or the average arms expenditures of the three, goes to infinity if their combined averages are larger than the margin. They approach the margin if their average expenditures equals the margin, and essentially go to zero if this is less than the margin. So mu, in this case, is an unstable equilibrium. In the scenario of two nations forming an alliance against a third, we'll be using the same policy model with differing enemy and our terms. The equations for America, Russia, and China appear here with their respective variables in the right places. If we take the coefficient matrix seen here and make it into this form, we can find the eigenvalues of this matrix. Using SAGE, the eigenvalues are 1 minus 3 alpha and 1. We can see these eigenvalues appear in the solutions provided by the author, where we have the 1 minus 3 alpha term and then some 1. We can simplify the equations by adding the x and y terms, seen here in full, to make a constant plus another constant times the eigenvalue term minus 4 alpha mu over 3 times n, and then z remains in this form. And since the 1 minus 3 alpha term is in between 0 and 1, as n goes to infinity, this term goes to 0. Which leaves us with the same equation for both sides of some constant minus 4 alpha mu over 3n, which is a line with a negative slope and positive y-intercept, meaning that as n goes to infinity, it trends to 0. For the third scenario, we'll use the same policy equation, but in this case, where a nation forms two secret alliances, China in this case does not have an enemy, which we will see in the system of equations in the next slide here, where America's enemy is Russia, Russia's enemy is America, but since China has no enemy, it's just this minus z term. Again, if this is placed in a system of equations and then a concurrent coefficient matrix here, we can solve for the eigenvalues in SAGE, which is the 1 minus 2 alpha, 1 and 0 terms, which gives us this system of solutions. As you can see, the 1 minus 2 alpha term here. And keeping the convention 1 minus 2 alpha is in between 0 and 1, then as n goes to infinity, the term goes to 0. So the equation would be left into this term as a constant, which is the average of the arms expenditures of America and Russia, minus this term here. And the author describes this as an expression that declines uniformly to 0. So in the case of a nation forming an alliance with two other nations that are all in the same triangle, then there will be an overall arms de-escalation. Let's propose a new model using the same policy equations from before. In this case, we'll be looking at a 1 versus 1, specifically between America and Russia. If we employ the same model used before, we get equations such as this, where delta x and delta y are the arms expenditures of America and Russia. Here is the system of equations including their coefficients, and here is the coefficient matrix. The SAGE code tells us that there will be a 1 minus 2 alpha, which we have seen before, and a 1 term. So we are left with 1 minus 2 alpha to the n c1 plus c2, and we get something similar for y sub n. Keeping the convention of 1 minus 2 alpha being between 0 and 1, it goes to 0, and we are just left with these two constants. Now, since we don't know the initial conditions that the author employed to make the other models, it is very hard to tell what these constants would be, but it would likely turn to a de-escalation situation if we consider previous variables of alpha and mu, and maybe some average of America and Russia. Thank you so much for watching our presentation, and we hope you enjoyed.